With this video short, I'm going to talk about significant figures. And really what I'm going to look at is, we're going to look at a bunch of examples of when we have zeros. So significant figures tell us, give us an amount of certainty in our values. Okay, and it also indicates our level of uncertainty too. Always the last either decimal place or the last whole number, if you're looking at numbers greater than 0, the last like numerical number, those kind of tell us the level of certainty that we have. But the significant figures, it tells us how many figures do we know to be true? Have we recorded? When I was an undergraduate, I used to crunch all my numbers on the calculator and I would leave every single decimal place in there. And that was such a waste of time because the values that were given are not that accurate, right? So they're not to 20 decimal places. And this little section, hopefully we'll talk about significant figures, calculating significant figures, and then how to perform calculations using significant figures. Okay, so these numbers are always going to be significant. Non-zero digits, any number between that's a 1 through a 9 in your number is going to be considered a significant digit. Captive zeros are zeros that are found in between two non-zero digits. So like 101, 101 Dalmatians, 101. That 0 is captive in between the two ones. So that is a zero that is significant. Trailing zeros are sometimes called lagging zeros. So you can have leading zeros that lead up to the first number, and then you can have lagging zeros that are zeros after a non-zero integer or digit. So when you have a trailing zero that's to the right of the decimal place, so small numbers like 0.10000, so to the right of the decimal place, those are always going to be significant. And any zero that's seen in scientific notation is going to be considered significant. These numbers are not always significant. Or sorry, these numbers are always not significant. Leading zero, so that's all the zeros that lead up to the very first non-zero number. So if I wrote 100 out as in 00100, the two zeros I put in front of the 1, which are totally pointless, are not significant at all. And trailing zeros that are to the left of the decimal place. So trailing zeros, see, this is where some examples are really going to help us out here. So trailing zeros to the left of the decimal place are not significant, but trailing zeros to the right of a decimal place are significant. So let's look at some examples here. Okay, so if I have this number right here that's 3090, okay, this I can say that the 3 and the 9 are significant digits, so I have 2 right there. I have a captive zero here, and remember, captive zeros are always significant because I know this 0 is an actual 0, right? The significant figures are really telling us what do we know is really true. And what do we not know is really true? Like, what are we uncertain about? Then I have one trailing zero, and notice this is a trailing zero that is to the left of a decimal place. There is actually no decimal place here, so this trailing zero is not significant. So in this value right here, 3090, I only have 3 significant figures. The 3, the captive 0, and the 9. This 0 right here is not significant. That would change if I put a decimal place right here at the 0. If it was 3090 point with that decimal place, that 0 then becomes significant because I know that it is exactly 3090 point, like point, decimal place point. Kind of talking about how significant figures tell us whether our certainty in a number, right? So if so 3090 has 3 significant figures, and that means that this number could really be anything from 3085 up to 3094 roughly. Okay, so that's just kind of this 90 at the very end, it's really we're uncertain of. So usually when we talk about, and some of the homework questions, it'll ask you what's the uncertainty factor. So if we use something like this, our uncertainty factor would be 3090 plus or minus 10. And we get 10 because the last non-zero integer is this 9 right here. It's really the last significant figure. And so then you always, so that's in the tens place. So this value is plus or minus 10. That doesn't seem that accurate really, but it depends on what you're measuring. All right, let's look at another example here. So here I've got a decimal value. So this was like a number that's greater than 0, and here's a number that's less than, well, it's not less than 0, but less than 1. All right, so here are my leading zeros. Remember I said all the leading zeros leading up to the very first non-zero integer are not significant. So these zeros do not count towards counting significant figures. All numbers do. This 8 and this 2, you know, all non-zero integers do count. So there's 2. I've got a captive 0. That always counts. So I've got 1, 2, 3 significant figures. Now the question is what about this trailing digit? Trailing 0. Now, since it's to the right of the decimal place, all trailing zeros to the right of the decimal place are significant. So if I were to give you a measurement, so this is 4 significant figures in this number right here. And if I were to give you a plus or minus to show the uncertainty, it would be plus or minus. Let me see if I can get my pen tool working here. Annotate, draw. It would be plus or minus 0.0000, where the 8 was, a 0 where the 0 is, a 0 where the 2 is, and a 1 where our last significant digit is, that 0 right here. Remember my plus or minus over here is plus or minus 10 because my last significant digit is in the tens place. And in this example over here, my last significant digit is in the like 100,000s place. What is this? 10, 100,000, 10,000, 100,000, sorry, in the millionths place. Right? Yeah, millions place. There's 6, you move the decimal 6 over. Okay, so that's some examples on significant figures. Now, lastly, let's kind of look at performing calculations with significant figures. My laser pointing back. Okay, so when we add or subtract numbers, the first thing you always need to do is figure out how many significant figures are in your numbers. When you add or subtract 2 numbers, the rule is it's the least number of decimal places. And I believe on the next slide there's some examples. Okay, but all you have to do is keep in mind the least number of decimal places. There we go, clear all drawings, okay. When you multiply or divide 2 numbers, the rule of significant figures is just the least number of significant figures. So if I'm taking one number that has 2 significant figures and multiplying it by a number that has 3 significant figures, my final answer can only be to 2 significant figures because that's the only amount of certainty I have in those 2 values. Okay, so then the last rule is kind of rounding numbers. So when you get that answer on your calculator, it's got a whole bunch of decimal places and you have to round to the correct number of significant figures, how do you do that? So if the digit that needs to be dropped, so it's the one immediately to the right of the one that you need to retain, right, is less than 5, you round it down. If it is greater than 5, you round it up to the next digit. And if the drop digit is actually a 5, so the number 5, that's the one you need to drop, you round up or down, whichever yields an even value for the retained digit. So let's look at some examples. Okay, so if I need to round examples so I need to round these numbers to 3 significant figures. So here might have been the number on the calculator, and how do I get 3 significant figures? These 2 zeros are not significant. This one is, this 2 is, that 8 is, and that 6 is. So I need to round my number up so that this 6 is the last digit. So look one place to the right and it's greater than 5. So I round it up. So the 6 becomes a 7. So 287. Let's look at this example here. So 3 significant digits. I have this 1, this 8, and this 3. So I have a 3 here. I look 1 decimal place to the right. It's a 3. So I need to round it down. So it stays 18.3. Okay, here we go. Here's an example where I got a 5. All right, 6.87. There's my 3 significant figures. Now I have a 5, right? Look 1 decimal place to the right. Oh, geez, it's a 5. Okay, so then what do we need to do? If it's a 5, you should round it up so that the 7 becomes an 8. So this is where that example where the digit that's retained needs to be an even value. Okay. So here's another last example, 92.85. I need 3 significant digits. That's 9, 2, and 8. If I look 1 decimal place to the right, it's a 5. Ugh. So what do? Do I round up or down? Well, I just keep it the same because the digit that's being retained is already even. So you keep it 92.8. So that's some examples of rounding. And I will actually post another video of, we'll actually cover in class extensively calculations with significant figures on Thursday. So that's where we'll talk more about the calculations.